Taman University Parit Raja, located in Johor, has experienced recurring flash floods, particularly in a specific area outlined in red. These floods result from intense rainfall events and pose a significant threat to the local community and infrastructure. The flood event was triggered by intense and prolonged rainfall, resulting in a significant volume of water runoff that overwhelmed the existing drainage system. The heavy rainfall, combined with the area's topography and inadequate drainage infrastructure, led to the rapid accumulation of water in the low-lying and vulnerable sections of Taman University. To address this issue, a comprehensive study is undertaken to identify the cause of flooding and propose effective flood mitigation measures. The problem statement, the recurring flash floods in Taman University Parit Raja have led to detrimental consequences, including property damage, disruption of daily life, and potential risks to human safety. It is imperative to analyze the underlying factors contributing to the floods and develop sustainable solutions to mitigate their impact. The objectives of this project is firstly to identify the causes of flash floods in the outlying area of Taman University Parit Raja based on the available data and analysis. Secondly, to assess the vulnerability and impact of the floods on the local community, infrastructure and the environment. Thirdly, to propose an effective flood mitigation method tailored to the specific conditions and layout of the area, considering its feasibility, sustainability and cost effectiveness. Fourth, to enhance the resilience and sustainable development of Taman University Parit Raja by implementing the proposed flood mitigation measure and reducing the frequency and severity of flash floods. And lastly, to contribute valuable insights and recommendations to the local authorities and stakeholders involved in flood management, providing guidance for future planning and decision-making processes.
Flash floods is a rapid flooding of low-lying areas, such as rivers and dry lakes. Flash flood may be caused by heavy rain associated with severe thunderstorms, hurricanes, or tropical storms. Flash floods occur within a few minutes or hours of excessive rainfall, a dam, or level failure. Flash floods can roll boulders, tear out trees, destroy buildings and bridges, and scour out new channels. Some safety things we can do are evaluate the furnace, water heater, air conditioner, and other utilities. Second, install check valves in sewer traps to prevent flood water backups. Next, construct interior barriers to stop low-level flood water from entering basement. Lastly, seal walls in basement with waterproofing compounds to avoid seepage, and do not forget to remove important papers and possessions from basement. Other than that, some safety rules during periods of heavy rain is to stay away from flood-prone areas such as stream beds, drainage ditch, and culverts. Next, move to a higher ground if flooding threatens the area. If we live or work in flood-prone areas, remain alert during periods of heavy rain. Be really cautious at night as it is harder to recognize flood dangers. Stormwater drain is infrastructure designed to drain excess rain and groundwater from impervious surface such as paved streets, car parks, parking lots, footpaths, sidewalks, and roofs. Stormwater system is designed to control the quantity, quality, timing, and distribution of storm runoff. Stormwater management is to protect environment, reduce flooding to protect people and property, and reduce demand on public stormwater drainage systems. Flood mitigation can reduce overall risk of structure experiencing flood damage and also reduce severity of flood damage when it occurs.
Now, I will present part of methodology. The first method that our group using to solve the problem is Manning roughness equation. Manning roughness equation is utilized to determine various parameters related to the flow of water in open channel, such as a cross-sectional area, channel slope, Manning roughness coefficient, or normal depth. The equation for Q is 1 over N times A times R power of 2 over 3 times S power of 1 over 2. Q is represent volumetric water flow rate passing through the stretch of channel. A is represent cross-sectional area of the flow perpendicular to the flow direction. S is bottom slope of channel. N is main roughness coefficient, and R is hydraulic radius. The formula for R is 1 over P. As we can see flowchart in this slide, there is flow to get value of Q. Next is channel dimension and area. The channel that using in this problem is trapezoidal channel. The dimension for this channel is the bottom is 3600, the top is 5600, and the depth is 1600. Next is friction slope. The friction slope is represent the energy loss due to the friction within the channel and is an important parameter for determining flow velocities and discharge. The formula for friction slope is highest value elevation minus lowest value elevation divided by length of the channel. Next is empirical IDF curve. Empirical IDF curve is equation allow for the minimization of error when estimate rainfall intensity value from IDF curve. The formula for empirical IDF curve is I equal to lambda times t power of k divided by d plus theta power of n. I is represent average rainfall intensity, t is average recurrence interval, d is storm duration, n is mean roughness coefficient, lambda, k, theta, and n is fitting constant depending on the rain gauge location. The last method is peak discharge estimation using rational method (RHM). Prior to calculate the peak flow using the rational method, it is crucial to establish the value of parameters such as area, time of concentration, rainfall intensity, and the runoff coefficient. The formula for RHM is Q equal to C times I times A. Q is represent design discharge, C is represent runoff coefficient, I is represent design rainfall, and the last one is A, water drainage area. As we can see flowchart in this slide, there is flow to find out the peak flow.
Hi and Assalamualaikum. My name is Muhammad Akil Hafzan bin Muhammad Arifin. I will be the presenter for chapter 4, which is data and result analysis. So for the data and result analysis, firstly, in order to do our calculation, we have to identify the location of the project or case study we have done as a group, which is in Taman University Parit Raja. The drainage we choose is the main drainage that convey through the network of the residential and shopping area. There are McDonald's, houses, residentials, and supermarket there. So therefore, we have to calculate the catchment area for those parts. The area of the case study area is estimated using by the Google Earth Pro. By using Google Earth Pro, we can calculate the area by using the polygon tools provided by the Google Earth Pro. The total area is 3.77 hectare. Why we use hectare? Because in the calculation or in the urban stormwater management manual management for Malaysia, the calculation use hectare and acres to do the calculation in order to simplify the calculation and to cancel out any other area or units that used in the equation. So from the slide shown, there are three pictures. The first two pictures on the left side is the area and the length of the channel. In other hand, for the right hand side is the picture of the flow of the drainage which is flowing towards the McDonald. As usual, before we calculate anything in the hydraulic subject, we have to identify the parameters of the channel. Firstly, we have to calculate the cross-sectional area of the channel. The channel or drainage is trapezoidal shape, which we have shown illustrated in the slide. The top width and bottom width and its depth is calculated on site with other group members for us to obtain. Meanwhile, for the calculation, we use Manning's equation and Manning's dose. We need to use Manning roughness coefficient. What is Manning roughness coefficient? Manning roughness coefficient is the degree or roughness of the surface of the channel. In this case, the channel used long grass type of cover to protect the soil and becomes the surface of the channel. We also have to find the slope of the channel bed. For example, we can calculate the highest elevation value and lowest elevation value. This value also gained by using the apps of Google Earth Pro. By using the apps, we can find and identify the elevation of the drainage bed slope. By using the equation given or shown in the slide, we use the highest elevation value minus lowest elevation value divided by the length or the span of the channel, and thus we get S, which is the slope of the bed slope, is equal to 0.0041. Furthermore, we have to calculate the time, intensity or time of during the rainfall. This can be calculated by using the equation shown in the slide. This equation can be obtained and can be thoroughly learned from the chapter 3, which is methodology, which is explained by my team member. So to finalize the calculation, we have obtained the intensity of during rainfall is 0.1053 hour. For this slide, we are going to show the calculation we have done to calculate the intensity rainfall on the catchment area or the studied area. So in order to calculate the rainfall intensity on the area, we must know the state, the station ID and the station name. This can be obtained from the Urban Management Stormwater Management form Malaysia. To finalize the calculation for the current channel or the current channel design of the drainage in Taman University Parit Raja, we must calculate the Q peak during the rainfall or storm of the area. This can be calculated by using the rational method, which will be using the rainfall intensity we calculated just now in order to get the Q peak, which is peak discharge, maximum discharge at that time. So we obtain the maximum discharge of 3.78 meter cube per second. Then after we have calculated the maximum discharge or Q peak of the current design, of the drainage in Taman University Bharat Raja, we have to calculate the new discharge value to be used as indicator to show that is the new design going to be sufficient enough to negate or mitigate the flood that occurred during the March 2023 this year at the Taman University Bharat Raja. So for our proposed new design for the drainage, we still are going to use trapezoidal cross-sectional channel, which is shown in the slide. We're going to enlarge the area by giving more depth and width of the channel. We're also going to do some adjustment on the elevation to increase the slope, hence increase the velocity of the flowing water in the channel. Because of the channel is influenced or be calculated by Q is equal to VA, we can calculate the velocity is influenced or directly proportional to the area of the channel. So firstly, to calculate the Q design or the new discharge of design, to do the comparison between the new design and the current design of the drainage, we can calculate the area as the first step. We can calculate the area and hydraulic radius in order to use the Manning coefficient. Plus, we are going to use the same surface in order to minimize the cost for reconstruction, for if the design is going to be used. We're going to use long grass cover with the Manning coefficient of 0.05. Hence, the new area of the cross-sectional of trapezoidal channel is 1.222 meter, 1.22 for its hydraulic radius, and the area is 10.9 meters squared. As for the last step, the last calculation for the currently design of the trapezoidal channel in the Taman University Bharat Raja, we must calculate the area, the hydraulic radius, the slope, and the time intensity and its rainfall intensity on the catchment area. The difference between the current design and the new design we have proposed is its area and its slope. Therefore, the amount of rainfall intensity it can withstand before its flow over or rise on the ground surface is 412.96 millimeter per hour. This means it can withstand a larger amount or a greater amount compared to the current design of the trapezoidal channel. By using the calculation shown in the slide, we can calculate we have enough information to calculate the new discharge of the designated or proposed trapezoidal channel for us in order to mitigate the flood being occurred again in the Taman University Bharat Raja. So in order for us to estimate the new discharge of the proposed proposed size and slope of the trapezoidal channel, we can calculate by using the equation shown in the slide, which is Q is equal to C times the rainfall intensity times area of the catchment divided by 360, and we have obtained the new design for the new discharge, which is 4.10 meter cube per second. And then we are going to compare between the current discharge for in the Taman University Parit Raja. We found that there are difference of 0.32 meter cube per second more of water can be conveyed through the proposed size of the trapezoidal channel, and it can withstand a higher rainfall intensity. Therefore, it can mitigate the flood by doing so. We chose to not widen or deepen the channel a lot more, because of there are not enough area, because it is close to the highway beside the channel, and it close to the parking area in front the shopping lot at the Taman University Parit Raja. By doing so, we can minimize the adjustment need to be done by doing small adjustment, and also improve the quality and the conveyance of surface runoff water to mitigate the flood being occurred again in the Taman University Parit Raja. Okay, that's all from me. Thank you.
Move on to the last part. My name is Umi Hafsa binti Muhammad Zaini, and my mistress number CF220001, and I will present the discussion and conclusion. For the discussion, from the data that was obtained in data analysis, multiple calculation is done to obtain the peak discharge of the current channel section known as a Q peak, and to design a new channel section that is sufficient to convey the surface runoff of water with high discharge value known as a Q design. So here's the result that we obtain from the data analysis and calculation. So for the length in meter, the current design and also the new design, we've got the same value, which is 490 meter, and for the depth in the current design is 1600, while for the new design 2000, and for the bed width, we've got the current design is 3800, and for the new design 4200, and the slope of the bed channel is 0.0041 for the current design, and for the new design is 0.0061 for the hydraulic radius. In the current design is 1.014 meter, and for the new design is 1.222 meter. For the rainfall intensity, for the current design 379.572, while for the new design 412.196 millimeter per hour. For the flow rate of the channel Q, for the current design 3.78 meter cube per second, while for the new design 4.10 millimeter cube per second. So next, for the comparative analysis between the current channel designs and also the new current design. So it is necessary to take into consideration factors like the channel dimension, the bed channel slope, and also the intensity of the rainfall when comparing the new and current channel designs. So for the channel dimensions, if the channel are greater or bigger dimension, then the flow having the higher flow to convey through the channel. So this is due to the channel cross-sectional area having an impact on the estimation of flow rate. It is directly inversely proportional to the water speed. So therefore, a channel with a larger cross-sectional area will often be able to carry a higher flow rate than one with a smaller one. Okay, next for the back channel slope. As you can see, the slope plays a significant role in determining the channel flow rate because the flow velocity is affected by gravity and the bending roughness coefficient. So this is because the water flowing freely in an open channel on a steeper slope move at a higher velocity than less steep slope. However, the water flow and velocity in the channel are also impacted by the channel surface roughness, and this also can be negated due to the same types of surface is used in both new and current design of the channel. And for the last factor is rainfall intensity. The rainfall intensity is the ratio of the total amount of the rain falling during a certain amount of given period. So in this case study, the intensity of the rain we estimated manually by using the competition follow in the Urban Stormwater Management Manual for Malaysia, known as MSMA. Influenced by the catchment area, which is the study area was given for the case study. It also includes the empirical IDF curve, which differ across Malaysia followed by its states and station. So for the state of Johor, the station ID that we use is Tor Daerah JPS Batu Pahat, since the case study on the Taman University. So we use the Tor Daerah JPS Batu Pahat. So hence, the rainfall intensity is obtained and the flow rate of the channel can be computed by using all the data obtained from the MSMA to finalize that the new design channel will be able to carry 0.32 meter cube per second more and have higher rainfall intensity of 412.196 millimeter per hour. Move on to the last chapter, which is conclusion. So to conclude the case study that we are in, so there are several processes involved in designing channel in urban areas. So there are numerous elements to consider when you designing a channel network. So to construct a channel and channel network, we need having a understanding of hydrology in order to estimate a rainfall based on its intensity, duration, frequency, known as IDF, by its states and also a station throughout Malaysia. So then, the engineer will able to compute and build an optimal channel that will be sufficient during heavy rain or a prolonged storm if they can predict the rainfall intensity at its maximum. So surely there are other factors such as roughness of channel, which influence the flow rate of a channel directly, type of development, and also a space for redevelopment and surface flow criteria which affect indirectly. So for the Taman University Parit Raja Johor, we know that lately we having a frequency of flooding during the monsoon season is also the increasing. So according to the instruction, the only adjustment that can be made to modify the channel design to a new channel design. So to simplify the reconstruction of the proposed design channel, the same surface of a channel is used, which is grass
grass cover channel, and the bed slope of the long end of the channel is increased by 1 meter, where the competition found sufficient to effect and also increase the flow rate of the channel, and the channel section area is also increased equally, particularly is that by 400 millimeter.